this morning?
Good.
Hey, we're going to take a look at a problem this morning. You can flip your papers over. And what I want you to do is I want you to read this problem to yourself. And the thing that I'm going to ask you is, what are we trying to figure out in this problem? So we're not looking for an answer yet. We just want to know, what are we trying to figure out? So go ahead and read it. And then I want you to turn and talk to someone that's right next to you about what do you think it is that we're trying to figure out in this problem. You may have to have a group of 3. Or you can tell me, and the rest of you can turn to your partner. So right here and right there. And just what are we trying to figure out in this problem real quick?
We're trying to figure out what the total amount is for the sales for the cakes.
For one of the cakes. What are we trying to figure out?
We're trying to figure out how much money can we get
And the
for
6 slices were $5.
So are we only trying to figure out how much for one cake?
No,
All
All 3. What are we trying to figure out, guys?
We're trying to figure out what was the total amount for the sale of the cakes.
Just one of the cakes?
So
All 3 of the cakes. So that's what we're trying to figure out, is how much for all of the cakes. So what do we already know that would help us figure this out?
Each cake was $5 each.
no, each cake was
Wait now, what was your name? Nicole said that each cake was $5. Is that, let's read and see.
no each slice.
Oh, each slice
Slice.
was $5. Okay, that's important. Okay, what else do we know that might help us?
Each
What was your name, sweetheart?
Emily.
Emily, what did you say?
There's 6 slices in each cake.
Is that important to know?
Yes.
Yes. Okay, so we know that each cake had 6 slices. We know that each slice was $5. And now we're trying to figure out how much. What is something you think you already know about the answer? Like, it's going to be more than or less than, or it's going to be about. You don't have to tell exactly, just like, what would be a silly answer? Turn and talk to your partner. What would be something that's silly? I'm going to let you talk to them.
I think
Why, and tell why you think that.
I guess like somewhere around 30.
What made you think that? It always explain to them why you think. How did you come up with 30?
Because basically 6 times 5 is 30.
each cake
So you think, do you think it's going to be more or less than 30?
30.
It's 30, so I think
And
it would be around
and each slice of cake is 5. Wait, but there's 3 cakes. So it would be somewhere around
Okay.
90.
So 3, 2, 1. So then, this is my question. I heard a couple of people say that they thought that the cost would be more than 30. Okay, how many people agree that it would be more than 30? You think it'll be more than 30?
Yeah, I think it would be 90 because I was doing 6 times 5.
And why did you multiply 6 times 5?
Because there were 6 slices and each slice cost $5.
Okay, and what did you figure out whenever you did 6 times 5?
He would get $30 for the when he sells a whole cake.
So can you say, I know the answer has to be greater than $30 because, turn and talk to your neighbors really quickly. Why do we know for a fact that it's got to be greater than $30? Go.
It has to be greater than $30 because each cake costs $30 And there's 3 cakes.
First, can you say what
I don't
she
even
just
think
said?
there's tabs.
So what was it that you, why do you know that it's gotta be greater than 30?
So it has to be $30.
Yeah.
And there's 3 cakes.
Ah,
At least it could be
okay.
around 30, but not exactly.
Okay, so we know, what I heard you say is that we know that we don't know exactly what our answer is gonna be yet, how much money they earned for all 3 cakes, but we know this, it's gotta be greater than 30.
Yeah.
Okay, so whenever, I want you to go ahead and I want you to solve this problem. Okay, put your thinking down on paper. I didn't say go yet. But whenever you get done, I want you to check your answer and I want you to see, is my answer greater than 30? Because if you came up with an answer of, let's say, 25, what would your brain tell you?
It's wrong.
And how would you know that it's wrong?
Because it has to be greater than 30.
Can you say that again really loud?
Because it has to be greater than 30.
Ooh, who can repeat what she just said? Yes.
It has to be greater than 30.
And instead of it, let's say the total cost of the cake. Can you say that?
The total cost of the cake is 30, so it has to be more than 30.
The total cost of how many cakes?
3.
But we're looking for the total cost of all of the cakes. So you could say,
There's slices.
right, Miss Ingram, I don't know how much all 3 cakes cost yet, but I know that it's got to be greater than 30 because, who can say that? I don't know what the total cost of all of the cakes is yet. Can you try that?
I don't know what the total cost of the cakes yet,
But I know this.
but I know that it would be more than 30.
Because why?
Well, because really I've been practicing this at my house.
Uh-huh.
That
But how do you know that it's got to be greater than 30? Can she help you? She looks
Yeah.
like she's really willing to say it. How do we know that it's got to be greater than 30?
Because 30 is the total price of one cake.
Ah. And how many?
Slice. One cake. Yeah, one cake. Like,
30.
One slice is $5. Yeah, one
Yeah.
slice is
$5.
So if you multiply,
So what does 30 represent again?
one cake.
One cake.
One cake? Okay. So we know that it has to be greater than 30. If I come up with an answer that's less than 30, then I know that I've done something wrong because I already figured out with my brain that the answer's got to be greater than 30. It has to be. That's why it's important for you to think about what you already know about the answer before you start working. Because then when you get to the end, you can go, hold on a second. I want to make sure that my answer makes sense. So I'm going to check it against what I thought at the beginning. Does that make sense? Okay, work it. Can you tell me what each one of those things means? Like, is that 30 cakes right there? What does that 30 stand for so far? What is that? What is that? Can you tell me what some of these numbers are? What some of them? You can just, like, out to the side write a little word. But it helps me understand what you're putting together. And, okay? So that makes sense so far. I understand what you're saying. Is that answering the question?
Yeah.
Really? How much? What is this? What is this telling you?
Since each slice is $5. I just put two slices together around 10.
Is that all of the slices that were sold?
No.
Okay, keep going. How many slices is that? Oh, you erased that one. Gotcha. I completely understand what you're representing right there. Good job. It's very easy to understand and it's accurate. So what's your answer for even 30?
Yes.
So you know that it makes sense, that it's reasonable. Okay? Keep going. I'm noticing that some people have a very efficient way of solving this problem. We're gonna talk about that in just a second. That is so clearly communicated. I can completely see what you're doing. Are you finished?
Yes.
Why don't y'all switch and just look at it. Look at her. She did it. See if you can understand the process that each person used. Ooh. So, okay. So are you close to answering the question that we're trying to figure out yet? The thing that you want to make sure that you're doing is stay very focused on what is the question we're trying to answer. Okay? So what part have you answered so far? So do you know how you can use that to figure out the rest of the question? I'm going to come back around in a second. How could you use that piece to figure out how much for all of them? Go. What did you think? And did it make sense, what she did? Now, check this. How many slices are there?
7.
So what is your name?
Francisco.
Francisco. One of the things that you do such a strong job of representing the problem, I think before you start, I'm going to give you a pointer. Before you start working it, I want you to go back like you did here and double check to make sure that what you're writing down matches what's in the problem. Okay? That's going to be important. Are you done? Do you have the answer to how much we earned for all 3 cakes? Yeah? You look hesitant. Are you confident in your answer? Will you switch with this gentleman right here and see if you are you confident yet? Do you have the answer to the question that we're trying to figure out yet, or part of it? All of it? Then will you switch with him? It's very, very important. Except for Francisco, right?
Yeah.
You can keep going. I just want to talk to the rest of you for a second. We're going to be doing this a lot. It's important not just that you know how you solve the problem, but it's very, very important that you can look at a way that someone else solved the problem and that you can make sense out of it. Okay? That's going to be very important. I'm going to come around this way. Now, Francisco is finishing up something, you did a lot of work here. All of you did. So something that I'm going to actually scoosh this over. Because I want to show you something. Oh goodness, I'm not seeing a dry erase marker right here. Maybe they're in here. I think I would need one.
Well, there's a black one up there.
Oh, you guys are so smart. Seriously. Okay. Just like in writing, we use, if I want to explain something in writing, if I want to write down the directions to something, what do I write down? What do I use as a writer? What is something that I write down on a piece of paper?
Word?
Yeah, words. Exactly. What else do I use as a writer? Yeah.
On your thinking.
You do, but my thinking is up here, so how do I get my thinking, which is blue? You can't see my thinking, can you? So as a writer, I use words. What else do I use?
Strategy?
What do I actually put down on the paper?
Words.
Words, which are made up of letters.
Pictures?
Sometimes we'll put pictures, it's true. Mainly in a story, we see words, and what if I said, oh no, my hair is on fire? What would I put at the end of that? Yeah, we use punctuation to help us explain our thinking too. Well, in math, we use numbers and symbols to help us explain our thinking. We write down our thinking using those things. So earlier, you guys helped me understand how much it costs for one cake. And this is how you did that. You said, Miss Ingram, we know that we have 6 slices per cake times $5 a cake equals $30 for one whole cake. Right? That's what you told me. Did this solve the whole problem? No.
No.
So what I want you to do right now on the back of your paper, or if you've got room on the front, you can do it on the front. But I want you I don't want you to use a whole bunch of extra numbers and symbols, but I want you just to use as many numbers and symbols as you need to show how you figured out for 3 cakes. So you can use numbers, and you can use the symbols in math. So that would be like a multiplication sign, addition, you can use an equal sign. You could use subtract. Do you think that we would use the subtraction sign in this step?
No.
No. We didn't take anything away, or we didn't find the difference in anything, did we?
No.
Okay, so write down using your numbers and symbols how you solve this problem.
The one of us has switched.
One of those way.
Like where we switched with a partner.
Oh, you can switch back with yours. Yeah, good question. Okay, and I'm looking to see who's going to do this. How are you going to quickly show your thinking?
Ow.
But what does that 12 represent? What did that 12 represent?
Figured out.
So how many, it's not 12, what would it be? Neil, you're using letters. In math, now there's nothing wrong with that, but what I want you to do is I want you to use numbers and symbols. Okay, just a number sentence, right? Can I see yours? Oh, you haven't done it yet? Ah. Now, what does that 30 stand for?
It stands for the total amount of the cakes
take this, I'm going to write down the list that you have so far. So I had one. Goodness. Who has another way I can write up on the board?
Well, I got one. Oh, wait, where's the?
Do you have one in? You have another one? Now, I'm gonna have to make you understand, we're not just, no, wait, let me explain. You're coming up with a way to come, well, I'm gonna write that down and we'll see if we agree with that one, okay? Okay. Now, these are some things, these are some ways that you wrote down how you would solve this problem, all right? Okay. I want you to look at each one of these, and I want you to decide, and this is important. I want you to look at each of these different expressions, these different number sentences, and I want you to decide, does it represent a way to solve, to answer this question? Not, oh, and this is the tricky part. I didn't say which is a way to get 90, because there's lots of ways to get 90. I could do 1 times 90, and that equals 90. But does that match this story?
No.
No. So with your partner, I want you to talk about which one of these do you think does a good job of representing this story? And are there some that don't represent this story? Okay, go. Talking with your partners. Y'all just need to scooch back a little bit so y'all can talk together.
I really think that 12 times 5
I think 10 times 9 doesn't work.
And the important word that I want to hear is because. Okay, why? You don't get to just say one matches or one doesn't match. You have to be able to explain why. Well, let's do these first and then we can talk about your way, okay?
Because it doesn't have any.
What?
It doesn't match the problem.
Does 6 times, do you think that 6 times 5 is 3 matches? How?
I think you get it.
I didn't even get 12 times 5.
But you know, one of the things that we want to think about is that it's not just because there's a 6 in the problem and a 5 in the problem and a 3 in the problem. Listen to how I explain this. I know that the first one represents it because there's 6 slices of cake, and each slice of cake is $5. So 6 times 5, and exactly, and there's 3 cakes, so that matches the story. Okay, so try the next one. What do y'all think about 18 times 5?
I don't know because I don't know if
That doesn't match the story.
Is there a hidden, where could that 18 have come from?
You have no words.
Where could that 18 have come from? First of all, I work backwards and I think, what does the 5 represent?
doesn't work because there's like no.
And how many slices are there? Altogether, there's 6. How many slices are there altogether?
18.
There's 18 plus
30.
Right. How many slices are there altogether?
Wait, I think that's I
18.
think that does match.
So would that work? Does that match the story? Yeah, it sure does. Was there one that you found that, how about everyone? Is there a,
I know, I'm putting 18 again.
Yeah, but 18 and then.
is there one of those that you said, that doesn't work? Which one is one that you said, Emily, right? Emily, what is one that you said, it doesn't work, and be ready to say why? And the rest of you, it's gonna be very important for you to listen. Do you agree with her reasoning?
12 times 5.
Because,
There's not 12 slices and there's not like 4 cakes. Because 6 plus 6 equals 12. But
and
like
you said that 12 doesn't match the number of slices? Who agrees with that reasoning?
I do.
Do you agree with that reasoning? I sure do. There aren't 12, there are how many?
18.
18, exactly. Was there another one that you didn't think matched the story? Yes, ma'am.
10 times 9 equals 90.
Now, it got the right answer. Why do you think it doesn't match the story?
Because there isn't 10 slices and each slice doesn't cost $9.
Who agrees with that reasoning? It's very important for mathematicians, okay, look right here at my nose. It's very important for mathematicians to make sure, hold on just one second, that whenever we're looking at things like that, that we make sure not just that it gets us the same answer, oh, it's 90, that must be it. We have to make sure that it matches, that the thinking that's shown there is the thinking that's in the problem. Okay, I want you to turn to your partner and I want you to say what Miss Ingram just said, that mathematicians have to be very careful and make sure what? Go.
Mathematicians have to make sure the equation matches what the what the word study is about. Not what problem and solve.
I totally agree. A mathematician
Equations has to match the problem. Just in your
Wanna go read?
because
is there